you, everybody, for being here. I'm Mike Vandersanden. I'll be talking about developing a holistic internet outage measurement system. It's quite a handful, and internally we just called it the Digital Vigilance Project. To summarize, what I did is I tried to apply a holistic approach to investigating internet outages. It's an approach we at Hasselt University have been working on in different contexts, from protocol logging with the Quick protocol to also trying to understand media applications. And in the context of the Internet Society Pulse Fellowship, where the Internet Society Pulse team, their mission is to help others better understand the availability, evolution, and resilience of the internet, I try to apply this approach to internet outage data. Because I hope we can agree that the internet is critical infrastructure, but there are quite a few interruptions. And because everybody relies on the internet, this has a great social and economic impact. When we look just at the shutdowns, which are intentional man-made outages, we can see that billions of dollars are being lost to the internet just being gone. And if we add all other kinds of outages, natural disasters, cables being cut, and other things, we can see that outages are a worldwide phenomenon, and everybody has to deal with the internet being gone at some point. Luckily, it's quite easy to check if the internet is doing well. You connect to some part of the internet to a server, and you try to measure that connection, and you can state if that connection is being good or bad. However, when you do many measurements at many variables, measuring from different regions, with different techniques, different kinds of protocols, and then other things, you can see that the results also start to vary, which makes it more difficult to give a single conclusive answer to the question, is the internet being healthy? And this is where the holistic approach starts to come in, because there are a load of measurement techniques and data sources, public data sources, that list their results. These different data sources have various things that they measure, connectivity, reachability, performance, usage, and also tracking of outages and censorship. What the holistic approach tries to do is combining all these data sources so we can leverage the different characteristics, start to cross-reference these data points of these data sources to create a knowledge base that helps us get a better understanding and a better overview of the data and of the internet. And with that data, we can start to inform the users by presenting this data in a clear way. We can also aid their analysis process, which can be manual right now. And we can also start to take action and automatically analyze the data and react to some event on the internet. The focus during this fellowship was on informing the user and aiding their analysis process. Because before the holistic system, and even right now, all these data sources have very heterogeneous interfaces. When we try to do a similar query for example, IOTA and Cloudflare, we have to really translate these queries and even the results to start to compare them, which requires manual and expert intervention when we try to work with this data. So what the holistic system tries to do is provide homogeneous interfaces, so we have a single, simple interface that we can use to query any data source, so we can quickly and easily get all the data we want. And then the system presents data in similar ways, so we can actually start to compare the data and put them next to each other without any trouble. In the process of making the system, we were able to find a couple of things. So, for example, the internet doesn't completely go down. It's always a part of the internet goes down, usually based on a region. We can also see there are different kinds of outages. So, for example, a cable being cut might take a couple of days to being fixed, or because some political reason the internet might be down for months. Uh, or in other cases we can see very tiny outages, lasting only a couple of hours, but they start to come back, every day or every few days. In the last case, we saw that there was a shutdown, so it was an intentional man-made outage. And in that case, or in the case of shutdowns, we can see that usually the parts of the internet that are being targeted, are being shut down, uh, are based on specific categories. Specific categories of websites are being censored. And in the same cases of shutdowns, we can see that they usually have predictable time and durations. So we might even be able to predict when the internet is going down, when we can start to see a pattern forming. And because we're working with patterns, we've also added some anomaly detection tools into the system, which are all customizable. So we give the user the power and ability to really fine-tune the detection for any patterns in the data. But the research doesn't stop here. We're also looking at maybe adding more data and maybe even real-time data into the system, because right now we focused on historical data. We're also looking, at the machine learning. Right now it's quite, DIY. We're trying to look at maybe more or better methods to identifying the outage periods, and maybe even finding the root cause of why the internet is down. And also we can keep working on improving the assistance and automation features of the system to reduce the manual work. But what I find most interesting is coming from an academic background and then working with students, that this topic really seems to engage students, because they've all experienced the internet being down at some point. They know the frustration that comes with it, so they want to learn about it, and even work on projects that uh, uh, are related to this topic. That was my Internet Society fellowship work, and I can take any questions now.
Thank you, Mike.
Thank you.
Do we have questions? See any question? No, no questions so far. Maybe a question to you, Mike. What has been the most challenging aspect of this project?
Uh, whew, good question. Uh, I think one of the challenging things has been trying to become an expert with the data, uh, because it's very heterogeneous. The different data sources do talk about the same things or the similar things in very different ways. Uh, and integrating all that data and then translating it and then getting it into the system in a way that's understandable and presenting it in an understandable way has been quite difficult. And even when it might be obvious for me, I've noticed in talking with colleagues and other people that uh, they all have another vision. So yeah, that getting that holistic vision that works for everyone has been difficult.
Yeah. No, and as you said, it's very heterogeneous. Like you have data at different frequencies and in different formats, so
Yeah.
it's not an easy feast. But I think this is a good start to try to aggregate different data sets and try to identify the causes. And this is actually a real use case that we have at the Internet Society, because as you know, we work a lot on outages and analyzing those outages, especially internet shutdowns. And having such a tool which can facilitate our analysis and allow us to be more reactive to those outages is necessary. So I'm hoping that we will get more fellows to actually continue this work.
That would be really
Thank
cool.
you. Thank you, Mike.